So why I am asking, so it's called backtesting. So what is backtesting? So let's say you have a data set. Okay. So let's say you have an array of, can you see my screen?
Yes, sir.
Okay. So let's assume that, let's say you are importing Y finances, YF import numpy as NP import fund. I think it will be, yeah. Let's see if we need pandas or not. So then you use data is equal to YF dot. Then you use the ticker. Ticker means, let's say you just use Apple. Okay. This the stock ID that is there in the stock exchange. Sorry. And then you use the period, and then you use, so how do you know about this? Okay. So when there is, when without using Google, so you can go here and you can just do this, and it will come on the right hand side. Okay, the function. Can you see the screen? So that's how you know. So you need tickers, that is which tickers you're going to do in the start and end, which may be none. And you can also use period and interval. So period means for how many days, let's say. So you can say 6 months. So you can see there will be examples below. Okay, here there are examples. So I think 6 months, and interval is, let's say, 1 day. Okay. So you will run it. So it's running. So the more you run it, so this is called documentation. So those who are learning to code and trying to learn, essentially you are using ChatGPT. Okay, but there are two phases of learning, guys. Okay, one is understanding that you can actually code if you're given the resources without using, like, for example, this is how I use ChatGPT. Okay, I do not ask it. So I do not ask it to. So how this is how I learn coding myself for new things. I do not ask it to give me the answer. I just ask it to, uh, let's say, give me the optimum thing. Okay, that helps me understand. So similarly, you can also do that too. Okay, so uh, you can ask ChatGPT and it will help you out in that fashion. So now this is a data set. So if you see data, it will be coming out like this. Okay, so what I will do is that I will change this into an array. So you can see the first, so data dot, so let's say columns. I'm saving the column names as this. The column names are saved. Now I, so it's, pandas are okay. So what is the difference between, this is a data frame. It's usually it's a data frame, and you actually work with it in using pandas. Now the difference between pandas and NumPy is the following. NumPy is a raw array, raw, you know, matrices or tensors, one-dimensional array or two-dimensional arrays or three-dimensional arrays or multi-dimensional array. But pandas are two-dimensional, and the thing is that you can actually access it by the names of the columns or rows. Okay, which you cannot do it in NumPy because there's no name. For example, if you just change it into uh, data underscore array is np.array of data. Let's see. Yeah. And you just show data. You will see now. Oh, data underscore array. Yeah, you will see now it's a raw now data set. Okay. the columns has disappeared, the column names. And the good thing is that if you work with the column names using pandas, that's okay to do, but that may actually you may need to do a lot of different things. For example, in this case, uh, it's a multi-index, so you have to reset the index every single time, and that's sometimes hard. Okay, that sometimes takes you away from the whole stuff. So I will be using just this raw data of matrices, matrix, and that will help you. So this is a data set. So if you want to just visualize it, just do this. You just do this as df is equal to data okay, so now I will introduce the pandas. So just import pandas as pd, and just if you want to visualize, just do this data frame of this data underscore array, and you can just do columns as columns. And if you just visualize this, you will see that our data set only. So see, the date and time were removed, but the column names are there. Even if you do not want to give the columns, it will look like this. Okay, so this is with, so now you have to access by 0 1, but this is just to visualize it. So this is the same matrix as the numpy array, but it's a better visualization, a tabular format. You can access it by the names of this. Okay, only this is the only difference. All of you understood this, guys?
Yes, sir.
Okay.
Yes, sir.
So now comes the next stuff, that what do I mean by backtesting? So by meaning by backtesting, this is the format. So if you remember the definition of a trading strategy, so as you can see here already, that it's a each time point is nothing but a multidimensional. So if you remember that, just remembering, that's why I like to give in a mathematical format. A data set is nothing but x is equal to x1, x2, dot 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 xn, or t is the data set we have, right? And you can see below what's coming. And I hope all of you can see properly. And each of xi is in r to the power d. In this case, above, it's d is equal to 5, right? Okay. In the case above, d is equal to 5. And what is a trading strategy? A trading strategy is nothing but a, let's say trading, you talk about trading strategy at a time t, because at time t minus 1, the strategy will be different mathematically, right? Because the moving crossover may be different. So a trading strategy is a function of time. So t at time t is a function of this x, right? Which is going from, therefore, it's a d, t cross d, therefore, right? The t time points of d dimension. So t is in columns, just like this. It's taking in this entire data set. So t is in columns, d is in rows. Sorry, I mean t is the number of rows and d is the number of columns. And this is going to this set, like buy, sell, or hold, right? This set it is going. So this is just a trading strategy, because at the tth time point, we are deciding based on some mathematical functions, like if the moving crossover. Now there's another thing. This function also have something called theta that we don't know. So this theta is unknown, right? So that's why we need back testing. Okay, let's do somewhere else. That's why we need back testing. Guys, can you see this zoom out thing? Can you see this? All of you? Is it visible, this text?
Yes, sir.
All of you, it's visible?
Yes, sir.
Okay. So that's why we need back testing. So what does back testing do? It does nothing but it divides this. So essentially it's based on past data, right? It's actually training. We are building, we are finding theta based on not on because if we take in xt, it doesn't make sense, right? Because xt is the right time point based on this. X t minus 1. The theta is found based on that. Okay. The theta is found based on that. We are finding based on the xt minus 1. And yes. So we are finding based on xt minus 1 and then we are testing on xt, or not testing, we are taking decisions on xt. Okay, based on xt. So it involves all of them, all t values, but this is how the decision making happens. Okay, so this is a small subtle aspect out there. Now, one important thing is that we sometimes, yeah, so what all of you guys done here is based on xt minus 1. So that's why backtesting is important, because it helps you in segregating this aspect. Okay, so in segregating this, so when you are actually sharing the data, you're actually sharing on this result, on this xt, this one, but actually you should share your data on xt, what it has happened on xt. Okay, I mean, it can also happen that you can divide till x, like till d minus 1, and you can also do it till this. You can also do it like x underscore d c dots. You can do it also like do it as this. Makes sense. So you can also do it like first d data points and take decisions, and then share your findings based on this. Yeah, so your findings or your results on helps you to find best theta. Okay, but you should share your findings on the data set you are tasting. Make sense, guys? Yes or no? All of and mathematics of financial data, right? But today we'll be talking about stochasticness of prices. So let's do some live coding. So let's say download, import y finance as yf, import numpy as np, import pandas as pd. So once we import them, let's get some price. So we get data, and then we do yf dot download. Then we have the ticker price. Let's say Apple ticker, and so
What did you use AAPL?
it's Apple stock.
Oh, I thought it was AAPL, the ticker.
And then there's a period. let's say you take a period of 6 months, and then you take, so you can know more about a function. If you forget, what will you do? You can just do yf download, and then you do a question mark, and if you do it, you will see on the right hand side, you will get to know about the function. So for example, the tickers, it can be an array too. So tickers, you can see it's a list, and then there's a period. It can be valid period is 6 months, 1 year, many things can be there, and then the interval. Okay, go to the parameters directly. So this is called a doc string. So and then there's the interval. An interval, let's say 1 day. So we download it.
You have to use AAPL, sir.
Oh, sorry.
That's what I was trying to say before too.
So once it download, once you download it, then you have to. So let's say let's see how it looks like. So what we will do is we will do data dot head. It looks like this. Now the thing is that this is a multi-index frame. Okay, so we want to. It's very hard to work in this. So we will. It's nothing but a matrix, right? So what we will do is the following. We will just convert this into a proper numpy array, a two-dimensional array. Okay, so we will use something called price 2D, and we will do it np.array and this data. Okay, and then we can visualize what this price 2D looks like. It looks like this. It's boring, right? So sometimes people what to do is they use pandas to visualize it. You can directly use panda here, but as you can see, it's not easy. Actually, it's not easy to deal with it. So to visualize it, what you do is you do pd.dataframe price 2D. The issue is that there is no heading to it. Okay, you can see the heading is gone. So you can actually use, I think data columns doesn't work. Oh, it works. So just give me a minute. Okay. So you can see, let's make a new data frame called columns. Just a list with this list. Close I. You can make low, open, and volume. What you can do is that when you do make this data frame, you can just add columns is equal to columns. Again, you can understand this function if you don't know, understand this function from. And now you can see this close high column came in. Close high, low, open volume column came in. You can just do head to just to see the top. Okay, but we want to work with this price 2D. Okay, because that's what we want. So now we will work with uh, the probability distribution, how it came. So we will close this. Also close this. Okay, so we'll now work with. So we have the price tool just to remind you. So if you look at price to shape, you will see it's 125 cross 5. That means there are 5 features. So what we will do, we will just take the first one. That is the close. I think it's close. The first one is close, yes. So let's just take the first one. So we will just take price is equal to first column. So the colon and then first column. Sorry, the second column. So now if you look at price, it looks like this, an array, a one-dimensional array. So now what we can do is the following. Let's investigate this price a bit. So we can just plot this. So for that we need to download this, import matplotlib. So observe that let's plot this plt dot. Now let's plot this price. It's one dimension, you will see this. So you also need to do plt dot show. So you will see this naturally came up, right? 125 days of data. Now we can do, this is an array and we can do an histogram of it. So what we can do is pl hist price and density is equal to true. If you do this, you will get this density. So what does it mean? It means it's kind of a continuous distribution like this. Now what you can do, another thing is you can divide this into price, let's say underscore categorical, you will say, or let's call it discrete. You can make it like this, np.where. So essentially you're going to replace. So let's calculate the average. So let's say, okay, say what I'm saying is that now if price 2D or just price, if it's greater than, let's say, mean of price or np.mean, then it's high, else it's low. So I'm discretizing the price. So if you look at this, it now looks like this.
So it's basically like probability kind of thing. What's the probability high or the probability low kind of thing?
Yeah. So this is what it looks like. Now how to plot this? And to plot this, so here it was continuous, so we plotted a continuous version of it. Now we will plot a discrete version. And for that, so for continuous we plot histogram, and for discrete we plot bar plot. So what we will do, we will first count it. So we will do values, comma. So essentially we need what? We need a number of unique values of high and number of unique values of low. So what we'll do, we will use something called np.unique. Okay. So you don't know this. So what you do as a student, you don't know this. I'm telling you. So what you do, you just run this and see what it gives. This is how you learn. Even without, so what I do is that I usually get to understand which function to use from ChatGPT, and then I learn on this own. Because in research, you will be creating or doing something that is, so in the future, we will learn, of course, we will learn very fast using ChatGPT. But a time will come, let's say after 5 years, 6 years, where people will learn very fast. And then ChatGPT training requires a lot of data, right? So then what will happen when new data are coming in, it's like it's not training itself right away, right? So it will be like delayed by 2-3 years of knowledge, which you need to learn quickly. So that's where you learn in this new way. Okay, that's why you learn in this, the process of learning should be the same, so that you can learn new knowledge. This is how you learn to code. This is how everyone learned to code when there was no Google. There was a something called documentation. This is a documentation, okay? So there is a NumPy documentation. So if you just sign NumPy documentation, you will see this. And you will see lot of like guides are there, like a lot of guide. And it's like every function has some meaning. So fundamentals, every function has some meaning. Okay. But it's hard to understand. That's why I use ChatGPT to learn that what function should be used, and then go to documentation or search here, like use that function, press and understand it. So how to understand a function? You see parameters here. That's why whenever you write a new something code from scratch, always write parameters, input and output. There's a returns and there is parameter. You can see. Okay. So how is it written? I will show you. Let's say after some.
Is input like an argument in a way?
Parameters is input arguments, and returns is what is the output of the function.
I'm just used to hearing arguments.
Huh?
I'm just used to hearing arguments.
Yeah, they write parameters. It's the same thing. Yeah. Tomorrow it will be a different name. So yeah, I mean you can see this, right? Arguments, but there's also called parameters. Am I doing something? Yeah. So you can say that np.unique takes in an array-like structure. Okay. And then there's a thing called access. Access tells you that in which, if it's a multi-dimensional array, then which dimension you want me to take the average of or uniqueness of, or is it the entire thing? Okay. So that's why it makes sense. That's why that's where the that's where the whole thing happens. So when you do np.unique, so that's why access is also important. But here we want to do the np.unique in the entire price. So we do in price underscore discrete, which you already defined above. And okay, so there's other things. So we want the count of it, right? We want, understand what we want. For a blur plot, we need the counts. Yeah, and the corresponding values, like values and the counts, like here high and low and their corresponding counts, right? As a pair. So, and does it give counts? Just see. Actually return the sorted array, okay. Yeah, so there's something called return counts. If it's true, return the number of times each unique. Okay, so we need that. So what it outputs? Outputs is okay. Values, the unique values, and the counts. Yeah. You can see an example here probably. Yeah, values comma counts here. Okay. So you can just so now here it's price underscore discrete. So now if you have done this, now if you look at values and counts, I don't know really, yeah. You can see it's high, low, and it's showing 45 high and 80 low. But we want mean of that. So what we do is that the values are same, but we change counts as counts divided by, what do we want? What do we want? Counts divided by?
I think it's 2, but I'm not sure.
No, it will be average of it. You want, so it will
So
be
the total number of terms.
the sum of the terms.
Mm-hmm.
So counts will be now average. So if you look at counts now, they're average. like it's now the sum of them is 1 now because it's a probability distribution. Now we will do bar plot, values comma counts, and PLB dot show. Now you can see it's a probability distribution. Okay, make sense, guys? Make sense? All of you, can you give a thumbs up? Okay, great. So now let me show some notes I have written for you for. Okay, another thing is left. Quite a few things are left. But yeah, so this is now the whole idea is this, that okay, so no, we are not done yet. We have some things left. So that means if you aggregate all the xi's, that is becoming a random variable. But each xi a random variable. So what we will do is that if you remember, price has shape 125. Okay, it's a 125 vectors. So what we'll do, it's 125 is 25 into 5, right? So what we will do is that we want to change this. I want to change this in. So I want to plot together the price of 5 days for 1 to 5, then 6 to 10, then 11 to 15, like this together. So what do we need to do for that? We need to change this 1 to 5, 5, 6 to 10, 10 to 11 to 15, all these things, this 5, 5, 5 arithmetic progression. I want to cut it and attach in the columns, right? So how to do that? There's a very easy function for Python to do that. We do it using reshape. So what we will do is we will write price now 2D, not 2D. Let's say price new as price dot reshape. Now when you reshape it, imagine now it's 125 cross 1 or 125 vector. Now we want to reshape it into 5 length. The time is 5 and 25 is the number of columns. So 5 rows and 25 columns. So 5 comma 25. Now you can see price underscore new. It looks okay. Let's now look at it in a data frame format. So pg dot data frame, so that you can visualize it. This is how it looks like. Each is a time series of 5 length. Each is a stock of. So you can, if you just say price, if you just look at the difference. Oh, just give me a minute. Okay. So it has distributed in a different format. It has distributed in, yeah, lengthwise. You can see that. Okay, it is distributed in lengthwise. That's absolutely fine. No worries. So just give me a minute. Just give me a minute, okay? Okay. So yeah. So it will be the same thing. There's something called order Fortran style. So we will use that here. So we will use order is equal to here. So now I didn't read this. So therefore what we'll do is we will look at the reshape. Okay. So np dot reshape. We'll read about it. Yes. So yes, you can see. So there is an order which I didn't read. So C is the one where it reads in the index order. F is the one to read. Yeah. Got it. So yeah, so it's a Fortran. So let's see. Yeah, now you can see the 1, 2, 3, 4. You can see the 1, 2, 3, 4 are the same here. Got it, guys? Yes, Raghav.
Why did you choose F specifically over C or A?
Oh, why did I choose?
Yes.
So because I want to plot 1 to 5, then 6 to 10, then 11 to 15, like this in a single way. I want each of them in single columns. If I don't have this, it was giving me, see, it was expanding this. So it was like there's a string. I want to do the string like this, okay, into a column, but they are doing the string row wise.
Oh, so it's just a different format.
Yeah. That was I was doing this. So now what we will do is we will plot this now. So we'll do PLT plot this price new. Great. So now you see that every time, okay, so one thing I missed. So I need to change this price new. So I want each one of them from 0, from 1, and I'm telling you why. So price new divided by price new of the first row. So you can see all of them are 1 now. Okay, there's a reason behind that. Yeah, so you can see that all of them 1 because I want to see that from every 5th day onwards, how do the, because I believe that after 5 days, let's assume that 5 days have no effect on one another. So you can see after every 5 day, like what I'm saying is that even if it started from the same value, this shows the path of a 5-day price movement. Okay, which tells you that today's price is just one of the options of one of such paths. Because we are only measuring relative distance, right? Because that's how we gain money. We do not gain money by absolute distance. We gain money by relative distance. Because we are dividing with the number. Because with a, let's say there's a stock price as a price, so we buy the number of shares of it. Okay. So let's say I have the stock price is 100. I use $1,000, so I buy 10 shares of it. So if tomorrow, if the stock price becomes 110, I'm actually gaining profit of 10 per 10 stock. So I get 100. I get because of the difference, not the absolute values. So therefore, if I do it with respect to 1, all of them are combined to the same initial value. Now I see the price change actual that can give us money. So this price change that you see, some 5, like it's, so what I'm saying is that each price path is just one of the options. So how do we model this? So if you remember that, it means we model this as x1, x2, x3, x4, right? But I'm saying this xy, each of the xi's is one of the options among its this. Yes, Raghav.
So I understand what you're saying about how the graph is showing the multiple options that any day could go over the next 5 days. Any stock could like go over the next 5 days. But how does the price underscore new equal price underscore new divided by price underscore new 0 like show what you're describing?
Yeah. So what I'm saying is that we want to change the, we want to only see the change, right? So if I mean, if I do not do this, it will be, you will be looking something at this, because every price has different starting point. So we are not actually, if we plot this, we are not changing, looking at not x1, because this is relative, which price change is relative to the starting point. So to see the stochasticness in it, the variability in it, we have to actually combine them to the same point and then see the variability. So that's what I am doing here. When I'm combining all the prices relative to the first day's price. That means I'm bringing all of them to day 1, and then seeing the, then like I'm seeing the flowering of the stock market for each different days. Am I making sense, Raghav?
Yeah, so I get what you're doing, but I don't fully understand how the code does what you are doing. So how does divide
Okay.
day?
So when I'm doing this, when I'm dividing by price new, so price new is nothing but the first row. Oh, right. So price new is nothing but the first row. So when I'm writing this, essentially I'm saying that divide each row by the first row. Like, so in Python, we write codes in factorized format. When I say A by B in Python, in between two numbers, is essentially divide by two numbers. But if I have an array, divide by two array, that means each element of the array is correspondingly divided by the same indexed element in the other array. Yes, Raghav.
All right, so like what you're doing is you're taking the first row and you're dividing each subsequent row by that first row to see how much it changes from the first. Okay, thank you.
Yeah, so that we normalize it to the first day, and then we see the change of the movement. We are essentially measuring how the price is changing with respect to the first day, as if the first day is the same. And so you can see the stochasticness here. And now what we will do is we will plot each one of this histograms. So we will do it as price underscore new of 0. Sorry, density is equal to show. So if we plot this, you can see this for one. For the next one, let's see. Oh, sorry, this will actually, I have not divided it yet. So if you see one, it will be just single bar. So it doesn't make sense because the first one is all one. Now it looks like this. So you can see that every time point is kind of a different distribution. Okay. So what I'm saying is that at each of the xi is the probability distribution in itself. And its exponential kind of increase. Stochastic process. So it's like if you take the log scale of it, the distributions are kind of similar, you can say. But you can see here that, yeah, if it's kind of increases with the, yeah, so that's the whole idea. So what I'm saying is that the main takeaway point is the following. So I've written some notes for you. So each xi is a random variable. Okay. And so each xi is a random variable. So now how would we measure randomness? We measure randomness by probability distribution. So in discrete values, we use something called bar plot, which is nothing but each xi takes values like high and low with a, which I am saying a1, a2 dot am with probabilities p1, p2 dot pm, where each of these is greater than equal to 0 and sum is 1, like we have seen here. Okay. And here, for this case, for continuous values, probability distribution is nothing but a histogram. So each takes a real number. Each xi takes real numbers with the probability distribution of fx, where fx is greater than equal to 0 and integration of that. So integration is nothing but the area under the curve. You can say. And you can think connect it by a continuous curve, let's say.
Are we are we using Riemann's integral or are we
Yes,
using
Riemann's integral.
Okay.
And the Riemann integral is 1. In general, you can use Lebesgue integral actually, but let's not go into the details of it. And this here, fx is not a probability. For because you can see if it's a probability, then it cannot take the value 12, right? So what does it mean? What does fx actually mean? So fx doesn't mean anything alone, but what it means that fx dx is the probability of x taking values in the interval x between x and x plus dx, the interval. For example, you can see that here 12 is not the probability, but at 1, 12 times is 0.01. That is, if you calculate the area under the curve, that will be 12 times 0.01 means 0.12. That is the meaning of the probability. So similarly here, fx times dx, the length of that and the height, actually calculates the probability of x taking values in the interval x comma x plus dx. And humans cannot really understand always randomness. So often we understand the distribution by its mean, median, range, variance, skewness, kurtosis, percentiles, like this values.
What is Kurtowskis? I don't know what that term means. I was just wondering.
So okay, yeah. So okay, yeah, I should have mentioned this. So mean is the average, median is also kind of the like
These are like data, like ways to measure the data. Not the variance, like Kurtowskis.
yeah, I will go to that. I'm just going, I should have mentioned that. So a range is the difference between maximum and a minimum. Variance is again the variability. Skewness tells you that it's how skewed it is toward the left or the right. For example, if you look at the performance of any student, okay, let's say an average student like me, if you take any performance, my performance is not symmetric around a number. Okay, my performance is always skewed towards lower value, and sometimes I perform well, so it's left skewed. Similarly, a really good performer is right skewed, who is always on the like a good student is always on the higher average or higher score, and sometimes the student can do lower scores, right? So that's what skewness measures. You can read the mathematics online. I'm not going into that because it will be just not good use of time. And then kurtosis is how much it's picked at certain point. How much is picked. Like the more the peak it is, that means the more dense it is. So you can say kind of skewness, variance is nothing but proportional to square of it. Skewness is nothing but proportional to the fourth power of it. So for example, just give me a minute. Yeah, so I've written this answer a long time ago when I was a school student. So I think it's 5 years ago. So you can see I have written like what does moment means. For example, a Taylor series expands a function in terms of square, x square, x cube. Similarly, so for example, all these coefficients tell you the how much x square is inside that function. Similarly, the first moment tells you the location and center of the distribution. Standard deviation tells you how much spread or variability is there. Skewness tells you how much it is right skewed or left skewed. Kurtosis tells you the peakedness of it. So the more the flat it is, the more negative it is, the more positive it is, more peaked it is. Okay. So essentially, higher moments tell you about more about this each of this. Um, so the odd order moments tell you about the symmetricity, because if they is symmetric, the positive and negative cuts away. Symmetric around zero, the positive and negative cuts away. So that's what odd order moments tell you. And Kurtosis tells you about, yes. So the even ordered moments tells you about how variable, how picked, and this kind of behaviors. So these are all complementary in nature. Okay. So I can actually cite this here for better understanding. So did you understand about this, guys? So therefore, what it means is that each one of them is a distribution in itself. So each xi is a distribution in itself. All of you are good with this, guys? Yes or no? Yes, Sai Pratisht.
No, I meant to click a thumbs up.
Okay. Can you give a thumbs up? Siddiq, Arnav, Raghav, Shawnendu, Shai Pratisht. Shawnendu, all good?
Yeah.
Good. Okay, so what's next? The next part is understanding that. So this is basic. So the next part is understanding that we have now understood x's individually. So our tensor is nothing but x's, right? Individually. So we have understood x's individually, but we have not understood yet the is there a relationship between x's? Are xi and x like are x1 and x2 related to each other? Okay, did we understand this? So that's important. Are x1 and x2 related to each other? So how to do that? So I would give that as a homework. So what you do as a homework is this. Take a plot. Take any xi sequence, x1, x2, xn, just like I've shown here. And then you plot the xi comma xi plus 1. Plot it. And see that do you find a relationship? Are they like are they randomly distributed? So do you find a relationship? Do it for multiple stocks. Then what is the relationship? What do you see? Yes, Siddiq.
So is this due for tomorrow or next week?
Tomorrow. It'll just take 30 minutes of yours. Yes, Raghav.
Is xi supposed to represent like the close price of like the
You can take
first-
any of them.
Okay, and then like xi plus 1 would be the second day or the close price of the next 5-day interval, the beginning of the next
No,
5
no.
days.
So just take, so just like I have done here, just take the price of any day. Close price of all the days. Just take a single NP array, close price of any day, all the days. And once you take the close price of all the day, then you calculate the first day, second day, third day, fourth day, these pairs, and plot them. Okay. So when you plot them, there will be points, and then you will see some relationships. And if you do it for multiple, you will see more relationships. So then based on the relationship, you tell me, your goal is to tell me that what will be your trading strategy. So does it give you trading strategies? Also, do this for different time points. So do this daily, okay? Take this daily. Do this for 5 days, 10 days, daily, let's say. Like interval equal to daily, 1 day. Let's not go more than that. And then you vary different period. That means you can do 5 days, 15 days, 10 days, 6 months, and see how it evolves for different stocks. Yes, Raghav.
So as we increase the period, we'll start to see more of a relationship. Is that what you're saying? And that's what we need to see, how the relationship builds.
Yeah, how the relationship builds and how, like, is there any period where you are not sure about the trade, like whether you should do a trading or not? There should be some period, otherwise everyone can make money always. So what are those? So these are quantitative methods that you find out, and this will prove you that xi and x, like the pairs, are not independent. They have some relationship, time relationship. Okay, this will tell you that. And yeah, that's it. And then tomorrow with this, we will be introducing two things. We'll be introducing three things actually. I'm just thinking what tomorrow. Tomorrow actually I will do the research thing because that will be your homework. And probably I will talk about a bit about Markov chain. Okay.